Hello folks, and welcome back to a distro day. So today we're going to be machining the most complicated distro I have ever attempted. Now you may remember a while ago we did the G-Skill build, which had all of these angular surfaces on the top, so the 3D machined crystals. Well, obviously we can use the same technique to make 3D surfaces inside a distro plate. Basically, I'm going to have to match the angles on the motherboard, but also what makes this particularly difficult is that both sides are double machining jobs, and one of the sides is used to house two heat killer glass tube reservoirs. So if you remember back in the 1000D project, I had all of the heat killer tubes arranged inside a distro plate. This is going to be similar with two tubes arranged horizontally in this distro, which is going to be eventually going into a fractal design case. So it should be really quite exciting, but it does also mean it's going to be very difficult. So what we're going to be doing is using this stuff, which is 10mm acrylic, and basically machining down on one side, doing the inside first. So we're going to start with that operation, and then we're going to finish up doing the outside, which will have some 3D milling work. And I'll guide you through which parts we're going to be using and why my decisions are going to be made in that particular way later on. But for now, let's jump into CAD, take a look at the actual plan itself, and then explain a plan of action, and then pop it on the machine, get it going.
Looking at the 3D model here, we've got our two faces that I've put side by side, which means we're going to be able to machine them at the same time. Now the front here has the heat killer tubes mounted directly into the front of it, right next to these 3D machined angular portion. Now this is the part which lines up with the motherboard armor, and the idea there is going to continue the theme of that straight into the distro plate itself. Now you'll notice throughout here I've added in extra bits of geometry, and this is so that I can get even toolpathing throughout, which we'll take a look in a little bit. As you can see, there's an awful lot going on here, so I've had lots of finishing passes and different roughing edges just to make sure that the work holding is always going to be secure and we're going to get the best possible finish for every single part. Also, I need to separate individual parts to make sure I'm going to be hitting the tolerances for each. Also, one thing that you may notice from the simulation here, I'm going to be going around the edge, but only to a depth that's going to allow me to do exterior chamfers in any of the 3D work. I actually want the whole piece to remain a single unit, because when we do the flipping, we want it to be able to locate all at once and not to have multiple different parts all needing servicing individually. So by doing it in one go, this makes it more rigid and also makes it a lot easier to machine later.
First part machined. Now we need to flip it over and start work on the difficult side. Now, one limitation that I've got with my machine is that I can actually only define 10 tools at a time in my control software. Now, first up, apologies for this noise. They're having everything renovated still next door, so all the noise is of course flooding over into my workshop. So bear with me, and I apologize if it's a bit loud, but we're going to get to the machining now. And basically the first step is we're going to get all the remaining holes drilled on this correct side after locating it on the bed using some 8mm dowel pins. And then we're going to work on the heat killer mounts. Now those are actually surprisingly complicated because we need to make sure they're the exact correct depth. And you'd think you can just go off the machine itself, but actually you need to have a proper reference point and measure it as you go, much like I'm going to be doing with my O-rings. So if you recall, I used the calipers to check the O-ring depth. We're going to be doing exactly the same thing on these. we're going to be measuring off the bed itself because that's the flattest surface that I have on the machine, not the top of the acrylic, because the acrylic is not flat. It can waver quite a bit. We're going to do a base operation. We're going to check how deep it is, and then we're going to do it again, but to the correct depth. And that way it should be nice and accurate, and making sure that we'll have a good tight seal on the O-rings and all the other important watertight elements. Then after that, we're going to move on to using a larger tool again to do the roughing work, and then we can start the proper 3D work. So for now, let's get these holes done, get the heat killer mounts properly integrated, and then we can do the 3D machining. So cue montage. So the heat killer tube mounts are now done. Basically what I did is I went over first at a higher depth, so I was 1mm off the base, and this allowed me just basically to have like a rough run and find out exactly how deep I'm cutting, especially relative to the surface of the acrylic, which might not be at 10mm. So it turns out this is actually pretty damn close, so I probably didn't need to do it at all, but it came through at 4.9mm. Now I'm aiming for 6mm in total, so if I had been 1mm lower, I'd have only been 0.1 off. So basically what I did is I did that and then ran it again 1.1mm deeper, and that should be pretty bang on. Most of the area should be within 0.1mm, certainly around this sort of size plate. Now with that done, we need to do the 3D machining. So the first bit we're going to be doing is we're going to be using one of these, which is a 6mm single flute polished cut end mill. And that's going to be doing both the roughing and the finishing around the edge, because we need to do a contour around the outside so that we can do the chamfers later. And then we're going to obviously have all the pockets done in a stepped fashion with a 0.5mm step down, and that's going to be done in the main section in the middle and on the end, so that we can then go over it with one of these, which is a 3mm polished cut ball end mill. So that's the same one that I used for the G-Skill rig, and it gives a really lovely finish. But the problem is the walls here are much steeper than in the G-Skill crystals, so to get around that, we're going to then finish it again with another tool, which is a 2mm ball end mill. So this is also a polished cut, and hopefully using a 0.1mm step over, we should be able to get really quite an even finish. Now it will never be crystal clear with the ball end mill, but it should be fine enough so that it can either be sanded down later or left just matte, because actually it looks quite nice when it's left matte with these blocks because they sort of pick up the light in ways. So let's get these on the machine and get it cutting. Well, I'm really happy with how the 3D machining has gone out. It's particularly difficult to toolpath that. I had to do so much extra geometry just to make sure that the lines would run over the edges and not wrap around and maybe cause problems making the edges soft or something. So I just wanted to make sure they'd be as crisp as I could possibly get them. But now we need to do the finishing parts of this distro. So that means, firstly, going over all the relevant parts with one of these, which is an 8mm countersink. Now what that's going to do is it's going to give all the chamfers around the outside, because they're on both the top and the bottom. It's also going to do the countersinks for the screws, and then it's also going to do a chamfer around the outside of the G1/4 ports, because when you're thread milling a G1/4 port, you need to have like a chamfer / countersink on the inside so that the threads don't tear. So when you put fitting inside, you don't want to have any sort of loose little wimpy bits of fitting. It needs to have a nice lead into the thread, and that's how you do it, by using one of these. So we're going to go from that one to one of these, which is a G1/4 Whitworth thread mill. And I use this for all of my ports that face the top. I don't use it for the ones at the bottom, because otherwise you have to mill underneath the plate. But luckily these ones all go from the top, and it's double-sided anyway. So we're going to go with the G1/4 thread mill. We're going to do a standard pass of that, just get it really nice and clear. And then we're going to finish up everything back using the 6mm lovely all-in-one end mill. Now this should leave a flawless finish around the outside, and to do that I'm going to cut it around once to get it down to depth, and then it's going to step in 0.2mm and go very slowly. But instead of using climb cutting, so sort of cutting into the material, it's going to use conventional, where it's going to be cutting around it in the opposite direction. And for acrylic, what that has the effect of doing is basically sort of evening it out. So it leaves a much smoother edge and should really pick up the light, and you'll be kind of basically able to have a polished cut straight off the mill. All I'm going to need to do is just give it a wipe down with a cloth and clean it up to make sure any coolant and stuff and little bits of fluff are out. Aside from that, it won't need any post-processing. Well, I'm really quite happy with how this came out, because it was far more challenging in some aspects than I was expecting, quite frankly, and other parts that I thought were going to be really difficult actually proved to be fairly okay. So the hardest thing by far was doing all of the cam. So you may have seen in the cam section there was quite a lot to do, actually, and the main difficulty is with all these angled pieces. The issue is I have to be able to machine over the edges to be able to get a nice crisp corner on them, because if you stop on the corner with a ball end mill, because it's round on the base, if you stop on the corner, you're actually going to be left with a tiny little lip. So if you're using a flat end mill, you can go right to the edge and you'll be okay. But with a ball end mill, you have to go over the edge to the point where the center point of the end mill goes onto the corner, or actually a little bit further, just in case of precision errors and things like that. So to do that, I had to construct an awful lot of three-dimensional support geometry. So Normally when you're toolpathing, you just use a lot of the surfaces that are already on the model. I had to construct new ones that were parallel and in line with the existing faces and extended them. And then I'd have to do separate operations for each surface just to make sure that the end mill would go over the front and it wouldn't have any strange toolpaths. Because when you have a lot of these angles, it's very easy for the toolpath to go into like an interesting sort of spiral fashion if you're using, say, the contour one. It can quite often, instead of just going neatly back and forth like you saw in the video, it can go back, forth, up, and a little bit to the round, and it stops. And basically, if you have interruptions to your toolpath, you're going to have interruptions on the surface finish. And I wanted to try and get the best surface finish that I could manage on my machine. So to do that, I needed consistent, smooth toolpaths. And that's why it was difficult. On the machining front though, what made it difficult was the fact that you have to hit a lot of different tolerances. So if we look at the front here, not only do we have the angled surfaces, which actually aren't that tolerance intensive, but these parts here, which are the heat killer tube mounts, are, because these have grooves for O-rings, and they also have mounts for struts that go around the outside of the tubes. And those have to be the exact correct height, well, within a certain tolerance, because if they're not, you won't get compression on the O-ring and it will leak. So it's the same sort of issue that you see with the O-rings, which are sort of more easily seen on this side. If you have your O-ring channels and they're not at the correct depth, obviously you're going to have incorrect compression on your O-rings, and that's exactly what will happen on the tube reservoirs if we flip it over as well. So that was a difficult thing to manage. Also, both of these operations are double-sided, so I had to make sure that everything was consistent along both. But we did manage it, and I'm very, very happy, especially with the surface finishes. I wasn't expecting the end mill to do quite such a good job on the angled surfaces. I used a 0.1mm step over, which is very, very small. And if you do that on metals, it's not necessarily the best choice because you're not cutting enough. But with acrylic, because it's so soft and it sort of chips very easily, you can actually use a very, very small step over to get a really even finish. So as I mentioned at the beginning of the video, this is going to be meshing with an X570 Aorus Extreme motherboard. So we've now got to get this all sent off, and then we can focus on the next builds that we've got coming, which are really quite exciting. So I've got my personal custom build coming out very soon, and that's going to be a really special one. We're going to have a lot more cutting like this in that, but we're going to have woodwork, we're going to have stainless steel tubing, we're going to have crazy aluminium work, turning, the whole lot. Distros, double-sided ones, simple. Everything that I've done to date is going to be in that rig, and it should be really exciting. Now, of course, the best way to stay involved in all that is to subscribe to the channel if you haven't already. Also, you can find us over on Discord. Our server's linked below. And you can also find us on Facebook, Twitter, Instagram, and builds.gg. I'll catch you next time, folks.